Assalamualaikum and very good afternoon to my examiner, Dr. Melvin Ganjet Hong and Sir Abdullah Muhammad Tahir. My name is Muhammad Fazi bin Baharuddin, and in this video, I will present my final year project 2, title of Design and Development of Hot Press Machine for Composite Material Fabrication Application. Table of content in this presentation include introduction, literature review, system design, system verification and simulation, result and discussion, and the conclusion. First, we're moving on into the introduction part. Composite material research, development, and manufacturing are all ongoing process since composite material have varied classes of material. For example, natural fiber composite material is very high in demand due to the advantage such as low cost, biodegradability, renewable source, and these natural fiber are easily available in the nature. Hand layup method is a traditional method that the most famous method that used to fabricate composite panel. For example, as shown in the figure below, this is the hand layup method that used to fabricate composite panel. Problem statement in this in my project, traditional hand layup method known as lag in pressure distribution, lag in pressure control, and thickness control of material. Second one is the void formation can easily form in the composite panel if the amount of pressure applied is not enough and the curing temperature is not suitable. And the third one, a non-uniform pressure during the manual resin impregnation can lead to a path of fiber imperfection. The fourth one, hand layup method is very low in volume process and product uniformity is difficult to achieve. So the solution is to fabricate a hot press machine for composite material fabrication. Objective of this project, the main objective is to design and develop hydraulic hot press machine for composite material fabrication. And it is divided into 4 specific objectives. The first one is to design a 3D model of this machine using SolidWorks software. The objective number 2 is to determine the visual performance of this machine. Objective number 3 is to develop a prototype of this machine. And objective number 4 is to validate the machine performance. Moving on to content number 2, which is the literature review. Hydraulic press machine is already being used in industry for manufacturing of metal, plastic, rubber, and wood. So this hydraulic press machine can be divided into 4 different types, which is 4-column hydraulic press machine, C-frame hydraulic press machine, horizontal hydraulic press machine, and 2-pillar hydraulic press machine. Theory behind this hydraulic hot press machine, there are 2 theories, which is the first one is Pascal law principle. Pascal law principles is involving in the supplying of pressure during the compression. So Pascal principle use incompressible fluid to transfer pressure. The pressure that transfer inside the system is equal in every area, and the force is enlarged by increasing the surface area of the second piston. Second theory is the PID temperature controller theory that control the temperature during the compression process. PID controller is a frequent feedback loop system. So this PID temperature controller compare the set point value of temperature that we had been set to the measure temperature on the system or the device. So when there is a deviation in the temperature, the heating process will keep on until the temperature of the measured device is same with the set point temperature. And after that, the heating process will turning off by the sensor. And when the temperature is start to go down below the set point temperature, the heating process will back turn on, and this process will keep on repeating. Computer-aided engineering analysis is used in the product development to reduce the time, cost, and improve the quality of this machine produced. So there are three main topics that we need to focus on CAD analysis. The first one is the boundary condition. Boundary condition is very important as it must correct as influence the result of analysis. And on the mesh setting, we need to see on the density of the element and the maximum aspect ratio value. Actually, both of these criteria, the density and the maximum aspect ratio value, is related to each other. The higher the density of material of the element, the better the result produced, and the lower the aspect ratio value of the element, the better the result. And the third one is the hardware performance. Hardware performance, this is because an examination of a component with high mesh density setting will take a long time, and this procedure may not be able to run on a low performance hardware. Next, we moving on to the content number 3, which is the system design. So the design requirement of this machine, there are 3 design requirements. The first one is applying uniform pressure during the compression process, produce composite with uniform thickness, and control temperature during process of composite panel. So as we can see here, the preliminary design of this machine. So this machine is designed based on 4-column structural form hydraulic press machine. So how this machine works? When we pump the hydraulic jack, it will push the middle plate of this machine upward, and it will compress the composite material that we put inside the mold. The movement of this middle plate is guided by the 4 rod steel, and this rod steel is attached to load bearing to smooth the movement. And there's three theoretical analysis is done for this machine part, which considered as the critical component. The first one is the upper plate. Upper plate is assumed as a 2D rectangle shape, and analysis by using a simple supported beam. By using maximum deflection formula, we obtain the maximum deflection is 4.309 millimeter, which is quite high, but we need to be aware that the compression of composite material will not reach the maximum load can be applied by this hydraulic jet, which is 152 kilonewton. Second theoretical analysis is the hollow rod. The dimension of hollow rod have outer diameter 26 millimeter and inner diameter 20 millimeter. By using maximum deflection formula, the maximum deflection of this hollow rod is 0.3180 millimeter, which is very low, and it will not affect the ununiform of composite panel thickness during the fabrication process. The third one is the theoretical modeling of heat transfer. The objective of this analysis is to determine the amount of time required to heat up the plate to 150 degrees Celsius. So the properties of heating element is a 3U shape heating element that supply power is 2000 watt. So in figure 3.7, we can see the free body diagram heating element that placed inside the plate. By using a heat transfer formula, we determine the amount of time required to heat the plate to 150 degrees Celsius is 814 seconds. Next is the control system of hydraulic press machine. Control system is divided into two, which is electrical control system and mechanical control system. The electrical control system involved in the controlling the temperature of curing process, and mechanical control system involved in the controlling the pressure applied during the compression process. Next, we moving on to content number 4, which is the system simulation and verification. As you can see here, there are two pictures. Figure number 1 is the 3D model of this machine, and figure point 2 is the exploded view of this machine that show the machine component. The FEA analysis is run to verify the result of theoretical analysis that had been done in content number 3. FEA analysis of upper plate is resulting in deformation of 4.203 millimeter, which is near the value of the theoretical analysis. And in this upper plate analysis, local mesh setting apply at the maximum deflection area with 1 millimeter element size to produce a maximum aspect ratio value at 0.2524. So this value of maximum aspect ratio is good enough, because we tend to reach the maximum aspect ratio value below than 10 to produce a reliable result. Next is the hollow rod analysis with maximum deflection is 0.3180 millimeter, also quite near to the theoretical analysis. And the local mesh setting also apply at the maximum deflection area with 1 millimeter element size and maximum aspect ratio, which is quite low, 4.089. So it is indicate that the result of this analysis is reliable. The third analysis is the heating element. So the heating element, temperature of plate is set to reach at 140 degrees Celsius to 150 degrees Celsius. And temperature, the first temperature reached at 150 degrees Celsius is at 600 seconds, and the whole temperature of the plate is steady around this range after 64 minutes. So we can see here the temperature and power supply characteristic, which is fluctuate based on the working principle of the sensor. Next, we moving on to content number 5, which is the result and discussion. As we can see in the figure, is the hydraulic press machine prototype and the mold prototype. So the design requirement to deliver a uniform pressure distribution and produce a composite panel with uniform thickness is achieved by ensuring that the middle plate is moved in a flat condition during the compression process. And however, the criteria of this machine to deliver an optimum to control the temperature during curing process is not achieved because due to time constraint and financial constraint. And next, we're moving on to the machine testing. Machine testing is by fabricating a panel. So panel number 1, as we can see in the result above, the average thickness of panel 1 that divided into 12 sections have a very high in deviation. So the higher percentage error is 46.43%. That refers to the reference panel, which is 4.2 millimeter. This high deviation of panel thickness are resulted from not enough mixture to cover the mold, poor mixture distribution, and reference panel are not used in the fabrication. And the panel number 2 is fabricated. So in this panel 2, the average thickness have a slightly low deviation of thickness compared to panel number 1. So as we can see here from the result, the middle section of this panel have a lower thickness compared to the side thickness, showing that the overcompress is okay during the compression process, causes middle plate to bend at the center of the plate. And an improvement is made before we continue to the fabrication of panel number 3. Improvement is made again by using a 4.2 millimeter polyester resin as the reference panel and placed at the 4 corner inside the mold. And number 2 is adjusting the mold level flatness using aluminum foil. As you can see here, there are two pictures, which is the reading of before adjustment and the reading of after adjustment. This reading is show the tiltness of this plate. And this is the result of panel number 3. In the panel number 3, the deviation of the average thickness is very low, and the average thickness is near to the reference thickness, which is 4.2 millimeter. The highest percentage error is 3.81% with deviation 0.16 millimeter. By taking the standard variation of drop wake impact test, the tolerance of this thickness is below and upper 0.25 millimeter. So as we can see here, the deviation with 0.16 millimeter is acceptable, and we can conclude that these machines are able to produce a composite material with a uniform thickness and uniform pressure distribution. And lastly, we're moving on to the conclusion. As the first objective is achieved by designing a 3D virtual model of hydraulic press machine using SolidWorks software. And the second objective is achieved because we are able to determine the visual performance of this machine by using SolidWorks software and run a static analysis and thermal study analysis. Second objective is partially achieved because we are able to develop the prototype of this machine, but unable to install the heating element due to time and financial constraint. And the fourth objective is achieved by the validation of machine with fabrication of composite panel. Lastly is the recommendation for future work in this project. The first one is by installing a heating element. Second one is use dial gauge to monitor thickness composite panel. So installing a dial gauge to monitor the distance between the upper and middle plate, and at the same time we are able to measure the thickness of composite material that compressed inside the mold and use a thicker plate. By using a thicker plate, we can avoid an overcompress from occur, and we can reduce a high deformation from occur that can affect the composite panel thickness. That's all from me. Thank you.